Isn't there like equation like y equals mx plus c or something?
Yeah, okay. So the equation of a line in general is y equals mx plus c. Excuse me. Um, what do you know about gradient?
It's like the steepness of a line. I don't know.
Yep. And any idea how you find it?
Um, no.
So gradient is m, the m part, and that is the change in y over change in x.
Okay, so yeah, okay.
So for this line, what's the change in y? What's change in x?
So, so change in y is like
And the way I would do it is I'd pick two coordinates that you can see that are on the line.
um. mm, no, I definitely don't know what I need to do.
So can you see any two coordinates that are on the line?
Like, um, is it the ones crossing like the lines past y and x?
Yeah. So any coordinate on this line?
Like, minus 2, 0,
Yeah.
and that's like about 6.5, 4, or 4.5. I don't know.
Um, just the easiest coordinate you can find.
Oh well, there's like 0, 1.
Okay, so those two. So this one's tricky because it's got minus, but okay. But so in between those two coordinates, how much has y changed? How much has x changed?
So y changed by 2.
No,
Oh no, by 3.
no. What's
Uh,
what's the y coordinate down here? What's the y coordinate up here?
so the y coordinate, the bottom one is 0,
Mm-hmm.
and the y coordinate for the top one is 1.
Mm-hmm.
So the change in y is like 1,
Yep.
and then for x, it's minus 2 and minus 2 and 0, I think.
Yep.
So is it 2?
Yep. And so that's it. So the gradient is a half. It's basically the change in x. So for every 2 across in x, it is 1 up in y.
Okay.
So the gradient is a half. And what that kind of means is for every 1 right, you go a half up. So 1 right, a half up, 1 right, a half up.
Okay, and why is it called like P?
They called it p, the straight line p.
Okay.
They usually call it L or L1 or L2. Um, if you want the fancy way of doing it, I'll give you the formula. Hang on, let's write this in. That is a half. And the fancy way of doing it is y2 take away y1, so that gives you the change in y, and x2 take away x1, and that gives you the change in x, and the two coordinates, just any two coordinates. So it was minus 2, 0 and 0, 1. And so for the y, 1 minus 0 gives you 1, and 0 minus minus 2 gives you positive 2.
Okay.
But yeah, that's it. Any questions there?
No.
Okay. So they wrote 0.5. That's very bad, I think. Terrible, actually. Always leave your gradient as a fraction, so you can see it's 2 right, 1 up, 2 right, 1 up. That's a much easier way to look at it. Okay, we have this graph. Yep. Let's try this one.
So do I need to first of all say like what points I see?
So yeah, that's kind of the best way to do it, to pick 2 coordinates.
Okay, so I see 0, 0.
So that's a great one. Yeah.
I see 15, 20.
Okay. Yeah.
And then do I just need to find the difference between y and x of those two?
Yep.
And is x the horizontal line and y is the vertical line?
And I think that's 14 and 20.
Oh, sorry.
Sorry.
And in the coordinates, so that means that x would be 14 and y would be 20?
Yep.
Okay, so the difference, I think, is probably, say, 14. Oh, wait. Oh, yeah. But it's just 14 and 20, isn't it?
Right, so which one is on top, which one's on bottom?
So 20 on top, 14 on bottom.
Yeah, so it would be like 20 minus 0 over 14 minus 0. Or you could write it as 0 minus 20 over 0 minus 14. And you'd get minus divided by minus, so same thing. So the gradient is 20 over 14. Can we simplify that?
Yeah, so you can get 10 over 7.
Yeah, and so let's leave it as that. 10 over 7. And actually, let's just 10 over 7. So this is just for part B, I'm thinking. So it's about 1.5, 1.4. So let's just say it's approximately 1.4, but 10 over 7 is the good answer. 1.4 is just for part B, just to help you visualize it. Okay, write down a practical interpretation of this.
I'm not sure.
So you know how 20 was the y and 14 was the x?
Yeah.
What does the y represent in this question?
It's like mx plus c.
No. In this particular question, with a lorry and all that.
All right. The distance travelled.
Yeah. So distance. What does the x represent?
The time.
And what does distance divided by time give you?
Speed.
That's right. And so a practical interpretation would be that this is the speed of the lorry.
Okay.
Speed of lorry. Any idea what the unit would be for the speed?
For speed, would it be kilometers per minute?
Well done. Speed of lorry equals 1.4 kilometers per minute, approximately. Or it means every minute the lorry travels 1.4 kilometers, something like that. Yeah. Any questions there?
No.
Okay, I just want to see what they said. And it's quite a common thing where they have this kind of distance divided by time type of thing. And so each minute it goes 1.4 kilometers. Okay, so they didn't even bother with speed. That's basically what speed means, 1.4 kilometers per minute. And so, yeah, when I said with this previous one, I said kind of what this a half means is for every one right, it goes a half up. One right, a half up, one right, a half up. And it's the same thing here. For every 1 minute, it goes 1.4 kilometers.
Okay.
Yeah. Any questions about that previous one?
No, I don't think so.
Okay. Any idea how you do this?
Okay, so I think I need to substitute the x into the equation for y.
Mm-hmm.
Okay, so the first one would be, so the minus 2 would be, so 2 times minus 2, so minus 4, minus 3. So y is minus 5. So I think what the first thing I need to do is then put...
Hold on. Not minus 5.
Minus 7.
Yeah.
Yeah. And then should I just do the workings out for each of them?
What would you do next?
Yeah. 1 times 2 minus 3.
You could. What type of graph will this give us? Y equals 2x minus 3.
Is it a cumulative frequency graph or?
Nope. What will the graph look like?
It'll probably be in like a straight line or something.
Yeah, because it's y equals mx plus c. So if you know it's a straight line graph, what you could do is just find the endpoint and join them up.
Oh, right, well, so I could just be like 2 times 2 minus 3.
Yeah.
So, 1.
Yeah.
And then, so if I plot minus 7 and then I plot 1.
Well, how do I plot those?
So minus 7 will be in coordinates minus 2, minus 7.
Yeah.
And then for 1, it will be 2, 1.
Yeah. And then?
And then you just do like a straight line from one point to the other.
That's it. And your method will always work for any type of graph. It's just if you recognize that it's a straight line graph, it'll save you some time. Any questions there?
No.
And there's a way to check your answer. You see on our equation, what is it when x is 0? What is y?
Minus 3.
Yeah, and that's what we have there. It goes through the y-axis at minus 3. And so that's a way, if you had to sketch a graph, that's one way to do it. You can say that has to be minus 3, and it goes, for every one right, it goes 2 up.
Okay.
Yeah. Okay. Let's try this one.
Okay, so if we did 2 times minus 3 plus 3, that would give you -3, and then if you did a 1 times 2 plus 3, that would give 5, and then and then you substitute the -3 and the 5 in by doing -3 -3
Mm-hmm.
and 1 5.
Mm-hmm.
And then you just draw a straight line from one point to the other
That's it. How can we check our answer?
by timesing y equals by timesing it by 0, and then if it's +3, then right.
And yeah, even just by glancing at it, you can see it goes through the y-axis at 3, and that's +3.
Yeah.
And for every 1 right, it should go 2 up. 1 right, 2 up, 1 right, 2 up, 1 right, 2 up, 1 right, 2 up. Yeah, for the gradient of 2. Okay, so let's just see. So there's a million of these. That won't give you any problems. So different numbers, same thing. Different numbers. This time you times by 4 and then take away 2. Same thing. Same thing. And you can see on the mark scheme, they have, lots of different methods. One is the table of values. One is the first and last point. And then another way you could do it. Let's take this one. I don't necessarily suggest this way, but where will this go through on the y-axis?
The line.
Yeah.
It'll go through the -1.
Okay. And for every 1 right, how many up will it go?
2.
Yeah, so I'll go 1 right and then 2 up, and that's all you need. You've got 2 points, and you can just draw the line for the whole thing.
Yeah.
So what do they wanted that to stop at 3 and go all the way down to, what was it, -2? Okay, there we go. So just different methods. Okay, this is the one I wanted to try. So hang on. I'll do this one. Okay, so any way you like. How do we do this?
So if you did -2 times a half, and that would be -1 plus 5, so 4, I think.
Yep.
And then if you do 4 times a half, and that would be 2, and then plus 5 is 7. And then you do -2 4, and then 7, and then 4 7, then yeah.
And then join them up?
Yeah.
-2 4, and then 4 7, and join them up. Fine. Any questions there?
So I just want to confirm. So in a test, when they give you like 6 points, like they've done here, so from -2 to 4, and you just plot those two, you'll get full marks.
Yeah, because you can see. I mean, if you wanted to, you could cheat now and just put X's at every point that if you wanted to, But that's a totally fine way of doing it. The only thing is, it won't work obviously for a quadratic graph or something. So if it's supposed to look like this, and you said, here's the first point, here's the last point, I join them up, because it wouldn't be a straight line graph. It would be ax squared plus bx plus c.
Yeah.
But for a straight line graph, if you just recognize it's y equals mx plus c, y equals something x plus something, then it's going to work. You only need the first and last. And even then, like this goes, it starts at plus 5. So you can just go y-axis 5, and then for every one right, go a half up. And so there you go. I could use those 2 points and just draw the line for the entire axes for the whole paper.
Yeah.
Okay, let's try this one. So it's not particularly, but anyway, it's a different type of thing. Let's try this.
So say if you do -2 times -2, so yeah, so it's so that's 4, and then so it's 3 minus 4, so -1.
You didn't say it was -4. You said it was 4. -2 times -2.
So is it 3 plus 4?
Yeah. So it would basically be it would either be 3 plus 4 or 3 minus -4, which is the same thing.
Okay, so yeah, fine. So 3 plus 4, which is 7.
Yeah.
And then 3 times -2, which is -6.
Yeah.
And then plus 3, which is -3.
Yeah.
And then you do -2, 7, and 3 minus 3.
3, and then
you just plot that, you just put the points and then like join them together.
And what's different about this line?
It's negative. It's going downwards.
And how would you know that this line is going to go down? Just by looking at the equation.
Because one point's lower than the other.
If all you had was the equation, y equals 3 minus 2x.
Because because the x comes after the first number?
Well, they could have written it as y equals minus 2x plus 3. So that's before.
If it's a negative number.
Correct. So if it's -2, that means for every one right, it's 2 down. So 1 right, 2 down, 1 right, 2 down, 1 right, 2 down. Any questions there?
No.
Okay. So we did positive number, we did fraction, and we did negative number. So we did one of each, at least. Okay. How do we do this? Or what is the answer? Any idea here?
I don't think so.
So basically there's an L2 somewhere and you have to say the equation of it. Anything you know already about the equation of L2?
It's parallel.
Okay. And so what does that tell you about it, or what does parallel mean?
Does it mean it's going in the same direction as L1?
Yeah. And anything else? Or what does that mean if it's going in the same direction?
It's positive.
Positive what?
Correlation.
No, that's scatter diagrams.
Is the line going upwards?
And how do you know the line's going upwards?
Because it's parallel to L1.
Correct. So what I'm getting at is it will have the same gradient if it's parallel.
Okay.
How can anything else? What will your answer look like in general?
So
It says it's a straight line and we have to find its equation.
will one of its points end up being higher than L1?
So like your very final answer, what do you know about the equation of a straight line in general?
I don't know.
General form of the equation of a straight line?
Or like y equals mx plus c.
Yeah, so that's what your very final answer is going to look like. M will be some number and C will be some number. So you just now have to find M and find C. How would you go about that?
So m's the gradient, isn't it?
Yeah.
So is m like the difference between x and y?
Yeah.
Okay, so for one of the x coordinates, so two coordinates I can see are -6 and 0,
Okay.
and 0, 3.
Okay.
And the difference between both is 6 and 3.
And which one goes where?
So y at the top.
Yeah.
So I think that's 6 at the top.
So from here to here.
Yeah.
So what was the change in y?
It went 6.
That's the change in x.
Oh right, 3.
Yeah. And so what's on top? What's on bottom?
So 3 on top.
Yeah.
And 6 at bottom.
Yep.
And then m is a half.
Yeah. Okay. So the m of L1 is a half.
Yeah.
So what can you do with that? We're trying to find the equation of L2.
Well, we know that it goes through 0, -5. So can we just plot those 2 points and then just like carry the line on?
0 -5 isn't on this graph.
Right.
Any idea what the equation of this line is, L1?
So is it y equals -5?
That's L2, so L1.
Oh, L1. So y equals No, I don't know.
So it's going to be y equals mx plus c. What is m?
Got the gradient,
Which is?
a half.
So y equals a half x. And how about c?
Um,
We were using it to check our answers.
plus 0.
No. It's the y-intercept when x is 0.
Minus. Oh, is it just? Oh.
So on this line, when x is 0, what is y?
Y is 3.
Yeah. And so c is 3. So when x is 0, y is 3. So m is the gradient and c is the intercept, the y-intercept.
Okay.
And you can see here, this point 0, 3, when x is 0, or this line c is 3. So for our L2, is there anything you know about it?
So, okay, so y is equals to c minus 5.
C is minus 5, yeah. And m?
Is that half x as well?
Yeah, m is a half because it's parallel. And it goes to the point 0, minus 5. So the other one's 0, 3, so the intercept is 3. This one's 0, minus 5, so c is minus 5. Any questions there?
Right, sorry. So if two lines are parallel, they've always got the same gradient.
Yeah.
Okay.
So let me just change to something different worksheet that I have, because it does the two separately. But basically, if you have to find the equation of a straight line, all you have to do is find m and c, gradient and intercept, and then just sub them into y equals mx plus c. Equation of a line. So these are kind of pretend exam questions, but they're good for this. Okay, so this one, oops, let's try it. So part A.
So is p like 3x or?
P is when x is 0.
So it's 5.
Yeah, and you can see just by looking at the equation, c is 5. Okay, and B?
That should be like y equals 3x plus 6 or something.
Yep, y equals 3x plus anything, including 0. Include minus, include anything. Okay, part 2. Question 2, sorry. Let's make this a bit bigger. If it will let me. Yep.
So is the equation y equals to 2x plus 4.
Yep. Okay, how about this one?
The gradient minus 3.
Yep.
Is that 5?
So as a coordinate?
So it's 0, 0, 5.
That's it. Okay. Okay, how about this one?
So is the gradient 3? So 0 minus 2.
That's it. Okay, this one. I have to zoom out. Let's see. So they want you to find the equation of this line.
Okay, so so two coordinates that I can see are 0, 5
Mm-hmm.
and 1, 3.
Okay.
And then the difference between 0 and 1 is 1. And then the difference between 5 and 3. Is that like, would that be minus 2? Or would that still be 2?
-2.
Okay, so minus 2. And then, so it goes minus 2 over 1.
Yeah.
And then I think it's like
And what is -2 divided by 1?
minus 2.
So that'll be a bit simpler. Okay, go on.
And then is it like y equals -2 plus -2x plus 0?
No. Plus c. What is c for this one?
Isn't it the number you would have you times x by 0?
So it's when x is 0, yeah? So when x is 0, what is y?
So when x is 0, y is 5.
That's it. And so it's 5. So when x is 0, y is 5, and the c is where it cuts through the y-intercept.
Okay.
Any questions there?
No.
Okay, and you can see, yeah, if it was y equals -2 times 0 plus 5, you would get 0 and 5. And the gradient, another way of doing the gradient would be go 1 across and you have to go 2 down. So it's -2. Okay. Okay, how about this?
Is the gradient just, for the first one, is it just -10?
So that's only when it's written in the form y equals mx plus c.
Oh, do I need to make it y equals in the question?
Yeah.
Okay, so would I do a, oh no, so sorry, say would I do 8 plus 10x?
Yeah.
And divide that by 2?
Yeah.
And that would just be, so y equals to 4 plus 5x. So it's 5.
Yeah. And b.
Write down the equation of a line parallel to this. So y equals to 5 plus 5x.
Okay. It's the same idea, except you get a fraction. To make y the subject, that's the same idea. Write down the gradient, so that's the same idea. Write down the equation of a line that's parallel, and it passes through that. I think that's okay. So this one, find the equation of this line. Okay, how would you find the equation of this line?
Okay, so would I do, say, one, so a, so do I just need to find the equation on that line?
Yep.
Okay, so a is equals to 0, 3,
Mm-hmm.
and b is equals to 2, 7,
Mm-hmm.
and the difference between 0, 3 and 2, 7 is 2, 4. Oh, yeah, 2, 4.
Okay.
And then I then just do 4 over 2,
Yeah.
and then that's just a half. Oh, no, it's 1 over 2 divided by 2. Is it 2?
Yeah.
Okay. And then, so it's y equals to 2x plus 3.
Well done. That's it. Got a first shot. And a silly question. Okay, so that's the end of that thing. So now back to my tricky questions. That was just a drawing. Yeah. Let's see. So there's lots of perpendicular. Yeah. And then we got there. Okay. Better do it. Okay, how do we do this? Maybe I should. What if it said parallel instead of perpendicular?
So if it was parallel, they would have the same gradient.
Yeah. And any idea if it's perpendicular, how to grade? What happens with the gradients?
If it's perpendicular, is it like I forgot. No, I forgot what the word was. No, I'm not sure.
So the perpendicular of m is the negative reciprocal, so it's minus 1 over m. So you basically change the sign and flip the fraction if it's a fraction.
Change the sign, flip the fraction. Okay.
So the two have to multiply to make minus 1, basically. Okay, so let's try it.
Okay, so how much am I write this down? Okay, so 2 points I can see are 0, minus 2, and 1, 1.
Mm-hmm.
And the difference is 1 and 3. And so it would be 3 over 1. So just 3.
Mm-hmm.
And then do I need to do that, make that into minus a third?
Yeah, so the perpendicular gradient is minus a third.
And then it's y equals minus a third x plus minus 2.
They tell you something else. It doesn't go through, it doesn't have the same intercept.
that passes through the point 0. Okay, so y equals minus a third x plus 1.
That's it. So any questions about that perpendicular?
So, no, I don't think so. Oh, actually, yeah. So, if you get a negative number, would you just leave it as? Would you just turn into a fraction without putting the minus bit at the start?
You would change it to a positive.
Okay.
Yes, this one. Let's do this. How will this work? So this is 16. I just want to see something quickly. This is a better one. Okay, how do we do this?
Okay, say an equation for L2 would be like y equals 3x plus 1.
Well, we could leave it as y equals 3x plus c.
Right.
And then how could you solve for c?
So do I need to think of like what would be if x was 0?
Well, they give you one pair of x and y.
Yeah, they say 3, 4.
So basically, when x is 3, y is 4.
Yeah.
So how could you use that?
So so
You could sub them in, and so basically the way this will work is 3 times 3, because x is 3, plus something gives you 4. So this time they've given you the y, and you have to find the c.
okay, so 3 times 3 is 9. And then would I just take the 9? Would I just minus 9 from both sides and then just get minus 5?
Yeah. And so what's your final answer?
Y equals 3x minus 5.
That's it. Y equals 3x minus 5. So you can just sub in the coordinates and use that to find c. Now let's try this one.
Okay, so would an equation of line L be y equals minus y equals minus 1?
What is the gradient of L?
1.
No. That's C. M is always the number in front of X, even if they put it second.
Oh, right. So it's -3.
Yeah. So M is -3. We need M2, the perpendicular one.
So is that like 3 over, no, 1 over 3?
Yeah.
So y equals to a third plus c.
1/3 X plus C.
Yeah, and then if I do the equation, and then if I did, so 3 equals to a third times 6 plus c. And then if I just go on, I've got one calculator, let me just do that real quick. So
6 divided by 3?
2.
Yep.
And then 3, and then, so c is 1. And the beyond will just end up being, so y equals a third x plus 1.
That's it. 1/3 X plus 1. Any questions there?
No.
Okay, so I just want to take a quick look at what the rest of these look like. Gradient in a straight line. So we did this time. Gradient in a straight line, practical interpretation. Okay, so those are the practical ones. Oh wow, look at this. You have to match those up. So that's drawing. Drawing. Find the value of Q. Okay, so when X is 1. Okay. There's more to this. There is more to this. I feel like we can continue this next time.
Yeah.
So it's a big topic, and it's like every year it's coming up. Okay, but in general, let's see. How do you find gradient?
Well, I understand it now. So yeah, that you definitely helped me a lot. Thank you.
How do you find gradient?
Gradient.
Yeah.
It's y equals. Oh right, so it's just y. So it's just changing y divided by changing x.
Yeah, and you can use the formula y, like second y take away first y on top, second x take away first x on bottom, or you can just kind of see yourself. And it means for every one right, how many you go up. What if your gradient is -3? What will happen with the graph?
If my gradient's -3.
Yeah.
So does that mean that what? So y will be below -3, or?
No. What's the difference between the two graphs? One gradient is 3, the other gradient is -3. If it has a negative gradient?
Oh, is it the line will go down?
Line goes down, yeah. And actually, so this one we said the gradient was a half. What is the equation of this line?
Y equals to half x plus 1.
Well done. And another line has the same C, but it's perpendicular. What would be its equation?
Sorry. The line's perpendicular.
Yeah.
So would that be like y equals -2x plus 1?
That's it.
Yeah.
Yeah. Yeah. Any questions for me in general?
I don't think so.
Okay, so yeah, no two ways about it. This is a difficult topic because even in the book it was rubbish. Okay, well done, Andrey. You're doing great, and look forward to talking again next week.
Cheers, thank you. Bye.
Have a good week. Goodbye.